equations. Suppose you had 2 cosine x, take away 1 is 0. Well, if you're subtracting two things and you get 0, the two things have to be equal. If this take away that is 0, well then this must equal that. 1 minus 1 is 0. 2 cosine x must be 1. Can't equal a half. A half minus 1 isn't 0. 2 cosine x must be 1. Okay, so we want to solve for x, so that's the instruction, solve for x. So first we'll solve for cosine x. We'll divide both sides by 2. So you have cosine x is equal to a half. Now, if this were inverses, if it were inverses, the cosine inverse of a half is x, we would get one answer. But this isn't inverses. There are many, you'd only get one answer because cosine inverse is only defined between 0 and 180 degrees. X can only be between 0 and 180. But that's not coming up here. Cosine x equals a half all over the place. Cosine graph keeps repeating. Maybe 0 is, so the y-axis is right there. So where is it a half? Here, and 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 here. And it keeps going to the left forever, and it keeps going to the right forever. There's an awful lot of answers. But you know what? It keeps repeating every 360 degrees. They keep repeating every 360 degrees. That's one answer. It's this number, and then add 360 degrees. Or you have this answer, 360 to the right, 360 to the right, 360 to the right forever. Even 360 to the left. So what you can do is you can find out the answers between 0 and 360. Here's one answer, that x value, and here's another answer, the x value right here. And then you find those two x values, and you can add 360 degrees or take away any multiple of 360 degrees. So the question is between 0 and 360, not including 360. Why not? Because if you take 0 degrees and you add 360, you're already including 360. So you don't have to include 360. 0 will include 360. You want to look for answers between 0 and 360. You can include 0, but not 360. Okay. So where is cosine equal to a half? Well, cosine half is positive. Cosine is positive in quadrant 1 and quadrant 4. Adjacent over hypotenuse. Adjacent over hypotenuse. And you say, oh, I know this. This reference angle is 60 degrees, and so is that. Now, the question is, what are these angles, and we'll be done. Well, this angle is just 60 degrees. Plus any multiple of 360 degrees. And we denote that by 360k. K can be 0, plus minus 1, plus minus 2, etc. Okay, now the other angle, you can say, well, it's just short of 360 degrees. It's 60 degrees short. So you can, which is 300. Or, so you can say x is 300 degrees plus multiple of 360. But in my opinion, that's too complicated. Because 60 was sitting right here. Why not just say this angle is negative 60? It's negative 60 degrees plus multiples of 360k. Now, you should make sure that what I just just put a box around is not just one value. It's many values. One value for each value of k you pick. And this here is also many values. I want you to see that they're the same list of numbers. They're exactly the same list of numbers. Take 300 degrees, add 360, add another 360, and write down these numbers. Write down 300, add 360, write it down, add another 360, write it down, add yet another 360, write it down, and start at 300, and take away 360. Take away another 3, and write it down. Take away another 360, write it down. Take away another 360, and write it down. Those are some of the numbers on this list. And then do the same for the bottom one. Take negative 60, add 360. Write down negative 60, because you added 0 360s. When k is 0, 360 times 0 is 0. Negative 60 plus 0 is negative 60. Write it down. Add 360. Write it down. Add 360. Write it down. Do it until you get it or not. Take negative 60, and I'll take away 360. Write it down. Take away another 360. Write it down. Look at your list. They'll be the same. Okay, that's the answer to the first column. Let's try another one. Suppose you had the tangent of x plus 1 is 0. If you bring the 1 over, you conclude that the tangent of x is negative 1. Well, okay, now, when it comes to tangents, they're a little bit different than their cosines and sines. If here's the y-axis, tangents go between negative 90 degrees and positive 90 degrees. It is one period is 180 degrees. For example, if you wanted to concentrate on that point right there, if you go from here 180 degrees to the right, to say right there, you'll find the same point. If you went 180 degrees to the left, you may not believe it, but you're going to find the same point. The period for tangents is 180 degrees, or pi over 2. Okay, so that's what we're going to add to the angle. We're going to find the reference angle and not add 360k, but add 180k. Now, where is tangent negative 1? Well, tangent is negative in quadrant 3 and quadrant 4. Remember, negative 1 is negative 1 over 1. So the opposite and adjacents are both 1, but one of them is negative. 1, 1. This time the opposite is negative. Well, you should know these angles. They're 45 degrees. They're 45 degrees. This angle is 45 degrees short of 180. 135 degrees. Plus multiples of 180k. This angle, 315, yeah, but I'll just call it negative 45. Negative 45 degrees plus 180 degrees k, which is the same as pi over 4 is 45. 3 times 45 is 135, plus pi over 2 is 180. 180k. Negative pi over 4 is negative 45, plus pi over 2k. Here is one set of answers. That's done, complete, if you wanted your answers in degrees. And here is another set of answers in radians. Okay, so if you wanted degrees, you should put down what I circled. If you wanted the answers in radians, you should write down what I have in the box. Okay, that one's done. For cotangents and tangents, you you add 180k. For the other four trig functions, you add 360k. Suppose you have a problem like this. Sine squared of x is equal to 2 sine x plus 3. 2 sine x plus 3. This is like a quadratic equation. If you consider u to be sine x, then this would be u squared. U squared is equal to 2. Sine x is u, plus is plus, and 3 is 3. So I'm going to solve this last equation. It's a quadratic. I'm going to bring everything to the left. U squared stays. The 2u comes over as minus 2u. The plus 3 comes over as minus 3. And now the right-hand side is 0. And I try to factor. Since it's u squared, I'll try u followed by number times u followed by another number. And the two numbers should multiply out to negative 3, the constant, but add up to the number in front of u. Well, the only numbers I know that multiply out to negative 3 are 1 and negative 3, and negative 1 and positive 3. These two numbers add up to 2, so that one's wrong. So these numbers add up to negative 2, which is right. So it's plus 1 and minus 3. And this equals 0. Now, if somebody asks you an equation that involves x's, like the original equation, and you say, I know this answer, u is negative 1 and u equals 3, people have every right to look at you very, very strangely. If you problem in x's and you give me an answer in u. Now, if this times that equals 0, then either u plus 1 is 0, either this is 0, or that is 0. What plus 1 equals 0? Negative 1. What minus 3 is 0? 3. For either u equals negative 1 or u equals 3. Well, let's recall what u was. U was sine of x. So either the sine of x is negative 1, or u, which is sine of x, equals 3. And you need to realize that the sine of x goes between negative 1 and positive 1. So sine of x can never equal 3, because that's not between negative 1 and 1. Okay, so the bottom line is the answer is going to be the sine of angles that give us negative 1. Okay, now x goes between 0 and 360 degrees. Where does it equal negative 1? In one place, right there. 90, 180, 270, 360. 270. So x can be 270 degrees plus multiples of 360 degrees. Why didn't I draw a triangle? Because when you get 0 or 1 or negative 1 for sines and cosines, you go to you can't draw a triangle. You have to go to the graph. Why can't you draw a triangle? Well, you try drawing a triangle of 270 degrees. You don't get a triangle, you get a straight line. I mean, if it was 269, you would get that. Or 260. But if you keep pushing this side lower and lower and lower, it's going to be on top of the third side. You don't get a triangle. And just for the record, that's why the sine, that wasn't 270 anyway. You would get this, I'm sorry. This might be 269. So you get this triangle. If it was larger, 269 and a half, you'll get this one. But when it's 270, it's going to be on top of one another. What I drew was 180 initially. Now, if you get 270, look at what the opposite is. The opposite's going to be 0. The opposite is approaching 0. If you're very, very close to 270, no, the opposite is going to be 1. That is, these two lengths, this length and this length, are going to be very close to one another. And when you divide them, you get 1, or if the signs are different, you'll get -1. In any case, there's the answer. X can be 270 degrees plus 360K. Or if you prefer, this is a multiple of 90. So there's 90. It's 3 times 90. It being 270. Okay, plus 360 is 2 pi k. That one is done. Okay, let's try another one. Sometimes you just get a quadratic equation. For example, what if you have this one? Sine squared x is equal to 4 minus cosine squared x. Probably 2 would be better. 2 cosine squared x. Now, what you might want to do is convert this to either all sines or all cosines. For example, I know that sine squared plus cosine squared is 1. If I bring this to the other side, I learned that cosine squared is 1 minus sine squared x. So right here, I can put 1 minus sine squared x. Sine squared x is 4 minus 2 times 1 minus sine squared x. This is just another way of writing cosine squared x. Do a little algebra. Minus 2 times 1 is minus 2. Minus 2 times negative sine squared x is plus 2 sine squared x. 4 minus 2 is 2. I'll bring the sine squared x to the right side. So now the left side is 0. When I bring it over, I have 2 sine squared x minus 1 sine squared x. That leaves me with 1 sine squared x. So that must be negative 2. 2 plus negative 2 is 0. You don't believe it? Take away 2 and you'll get that. Negative 2 is sine squared x. Now this has no solution because you can't square anything and get negative 2. Let me just be sure I didn't make a silly error. No solution. Nothing squared. Something's being squared here. You can't get negative 2. Not going to talk about imaginary numbers. Okay, of course, in the last problem, instead you could have gotten rid of sine squared x by putting 1 minus cosine squared x. How about 2 sine of 3x minus 1 is 0? This minus that is 0. Then this equals that. 2 sine 3x is equal to 1. Okay, I want to solve for sine of 3x. That is, I divide by 2. So now I learned that the sine of 3x is equal to 1/2. Now this one's a little bit different because the angle is not x. Now we know that x we can go between 0 and 360 degrees. But we have 3x. So I multiply each side by 3. 3 times 0 is still 0. 3 times x is 3x, and 3 times 360 is 1080 degrees. So I want to go out to 1080 a half. And this is on our sine graph. 1, 360, 2, 360s, 3 360s. 90, 180, 270, 360, 450, 540, 630, 720, 810, 900, 990, 1080. And here's the y-axis. I want to see where I get a half. Well, I get it here, and here, and here, and here, and here, and here. Okay, the question is, what are those values? Okay, so where does cosine of x equal a half? Well, between 0 and 360, it equals a half in quadrant 1, which makes this 30 degrees. Fine, right? And also in quadrant number 4, you also have 30 degrees. So you have this angle right here is 30 degrees, and let me try this again. Sine is positive in quadrant 1 and 2. Sorry about that. So we go into quadrant 2. The sine is 1 over 2. That's 30 degrees. So this angle is a little bit less than 180. 30 degrees less. It's 150. So we know that we know that 3x can be 30 degrees, or 3x can be 150 degrees, plus 360k, plus 360k. But in the end, I don't want to know what 3x can be. I want to know what x can be. Now, the question is, what's this angle? Well, we know that that's 30 degrees. 360 plus 30 is 390. 3x can be 390 plus 360k. What's this angle? Well, we know what this angle is, our 480. This angle right here is 480. 360s here, add 90, get 450, and that angle is, 540. But this is 30 degrees less. It's 30 degrees less, so it's 510. 3x can be 510. We know right here is 720. Add 30 degrees, get right there. Add 30 degrees, get right there. 7 plus 360k. 720 plus 30 is 750. So 3x can be 750 plus 360k. Okay. 900. Yeah. This angle right here is 900 degrees. We have to go back our 30. If I'm not mistaken, that's 870. So 3x can be 870 degrees plus 360k. 3x can be 870 degrees plus 360 degrees k. Okay. Now I'm going to erase a lot on the left, and then we'll write down the final answer. We just found out what 3x can be, but the problem is stating solve for x. All of these problems say solve for x. Well, this first one I divide by 3x divided by 3 is 3, excuse me, is x. 30 divided by 3 is 10. 360 divided by 3 is 120. Next one, divide by 3. X is equal to 50 plus 120k. Next one, divide by 3. 130 plus 120 degrees k. Divide by 3. 170 plus 120k. Divide by 3. Get 250. X is equal to 250 degrees plus 120k. The last one, divide by 3. 40. Guess it's 290. Yeah. 290 degrees plus 120k. So here's your answers. They're a bit harder when the angle is other than x. If the angle is 3x, you have a lot more work to do. What if the angle is half x? What if the angle is half of x? What if I tell you, let's do cosine. Cosine of x over 2 is the square root of 3 over 2. So, x always goes, for sine and cosine, between 0 and 360. Well, if I divide by 2, then I need to only go between 0 and 180. And I want to know the cosines of which angles give me square root of 3 over 2. Well, square root of 3 over 2 is positive, and that's quadrant 1 or 4. In quadrant 1, we have adjacent over hypotenuse. This is 1. So that angle right there is 30 degrees. And if you wanted to bother to go to quadrant number 4, this is also going to be 30 degrees. So we can call it negative 30. But again, we're only supposed to go up to 180. So we can only do quadrant 1 and quadrant 2. We didn't even have to go out to quadrant 4. So what we have is that x over 2 can be 30 degrees plus multiples of 360 degrees. Double both sides because I want to solve for x. X can be 60 degrees plus 720 degrees. Okay. Now, I just want to make sure that x over 2 can't be negative 30 degrees plus 360. If you double this, 360k, excuse me. This is negative 60 degrees plus 720k, which for the record is 660 plus 720k. 330. Yeah. You can do everything I said. There is no point in even stating this at all. Okay, so there are your two answers. This answer and this answer. looking at the last one, there's a lot of duplications going on. It's not really in front of me anymore, but let me see if I can show you. For example, this line and this one. That equation, which I kind of circled, and this equation, they're both the same. Why? Because this one, 50 plus 120k. So let's just redo that one. Let us redo that one. See if I can even figure out which one that was. I think I made it up. So let's do one. I blew that one. That would get you most credit the way I did it. We had all the answers, but what I listed had a lot of duplication. Suppose you have the sine of 3x is equal to 1. Okay, sine of 3x is equal to 1. Well, where does sine equal 1? It equals 1 right here at 90 degrees. 90, 180, 270, 360. So 3x can be 90 degrees plus multiples of 360k. Multiples of 360. Divide by 3, x can be 30 degrees plus 120 degrees times k. And there is your answer. Done. A lot simpler, huh? A lot simpler. If I would have said that the sine of x over 5 is equal to 1, well then x over 5 must be 90 degrees plus 360 k's. Multiplied by 5. X must be 450 degrees plus 1800 degrees K. Okay? I multiply this by 5, I got X. I multiply this by 5, I got 450. I multiply this by 5, I got 1800 K. Problem is done. Not like the messy way I did it earlier. Sorry about that. How about you have this? Sine squared x minus 2 sine x minus 3 is 0. This, believe it or not, is a quadratic equation in some variable. The variable is sine x. For example, if I let u be sine x, that is, wherever I see sine x, I put u. Well, if u is sine x, then u squared, if I square the left side, I have to square the right side. If I square this, I have to square that if I want to say that they're equal. Okay, so wherever I see sine x, I'm going to write u. In this equation, wherever I see sine x, I'm going to write u. Wherever I see sine squared x, I'm going to write u squared. So sine squared x minus 2 sine u minus 3 is 0. First thing I see is sine squared x. Well, that's u squared. The next thing I see is a minus sign. The next thing I see is 2. The next thing I see is sine x, sine x. But that's u. Then I see a minus, then I see 3, then I see an equal, then I see 0. All I did was substitute u squared for sine squared x and u for sine x. Now, the brand new problem, we have to factor this. Since it's u squared, I'll try factoring it by u followed by a number times u followed by another number. And going to still equal 0. The two numbers should multiply out to -3 and add up to the number in front of you. The only two numbers I know that multiply out to -3 are -1 and 3 and 1 and -3. The first two add up to 2. That's gone. The next two add up to -2, which is what I want. So I put the two numbers. 1 is +1 and -3 is -3. This times that equals 0. So either this is 0, which means u is -1, or that's 0, which means u is 3. Now, you can't say, oh, I'm done, u is -1 and u is 3. Somebody gives you a problem, the very top line, they give you that problem that involves x's, and you tell me what u's equal, you have to tell me what x is equal. U is sine x, which is -1. And u is sine x, which is 3. Now remember, sine x is only go between -1 and +1. Sine x can never be 3. So sine x is -1. Between 0 and 360, it's -1 at 270. 90, 180, 270. And 360 degrees away. So x can be 270 degrees plus any movement of 360 degrees. Radians you asked for? 270 is 3 times 90. Here's 3 times, and here's 90, pi over 2. And 360 is, well, there is 2 times 180. There's 180. There's 2 times 180 times k. Okay. Now, if your teacher asks you to find the answers in degrees, it's the top one. Your teacher says find it in radians, it's the bottom one. Teacher says it's up to you, then you include one of those two. Teacher wants both, you include both. How about this one? Suppose you were told that sine squared x is equal to 4 minus cosine squared x. So, you'd like to get everything to have sines or cosines. And we have a way to convert. We know that sine squared x plus cosine squared x is 1. Well, if we brought the cosine squared over, we get sine squared x is 1 minus cosine squared x. If instead we brought the sine squared over, we'll have that cosine squared x is 1 minus sine squared x. So, for example, I can get rid of the sine squared x. It's 1 minus cosine squared x. And this is 4 minus cosine squared x. Now, whatever this is the same. Okay? So, from 1, we're taking away something, and from 4, we're taking away the same thing. You know what? Those are never equal. Those are never equal. You can't, one student can't type 1 in the calculator, and then one other student type in 4, and then they both take away the same amount. And they could both do that. Of course they could. But they won't get the same answer. They won't get the same answer. So at that point, you should be able to see that there's no answer. If you can, let's bring all the cosines to the right. Let's add cosine squared x to both sides. So it's no longer in the left side. The left side just has the 1. And coincidentally, when I add cosine squared to the right, it cancels out on the so you have 1 equals 4. There's no solution. 1 never equals 4. Okay? There's one way to have done this problem. That's using this substitution. Sine squared x is 1 minus cosine squared x. What if I use the other one? That is, instead of cosine squared x, I'm copying the top line, but instead of cosine squared x, I write 1 minus sine squared x. Okay, so what we have is sine squared x is equal to 4 minus 1 minus a negative, so that means plus sine squared x. So we have sine squared x is equal to 3 plus sine squared x. That can't happen. You can't have something and say that it's 3 more than itself. If I take away sine squared x on the left, I get 0. If I take away sine squared x on the right, I get 3. No solution. So no matter how you do this problem, there's no solution. But it could have been that sine squared x is survived, and we would have had a quadratic equation only in sine squared x. And you have to solve that. Now, let's see what goes on here. They tell you that secant x minus tangent x is equal to cosine x. Now, probably the best way to do this problem is to realize that sine squared plus cosine squared equal to 1. Now, if I divide everything by cosine squared, sine squared divided by cosine squared x, that's tangent squared x, plus, that I think you should see is 1. And 1 divided by cosine squared x is secant squared x. Ah, okay. I was about to say that if you bring this to the other side as minus, then this mess is 1. But that's not this. That's not this. They're not, the secant and the tangent aren't squared. So I was wrong in that note. Not the worst situation. So what I want to do is, I'm going to write everything on the top in terms of sines and cosines. Secant of x is 1 over cosine x minus tangent of x is sine x over cosine x, and this is equal to cosine x. So what I have is 1 minus sine x over cosine x is equal to cosine x. Well, just like with any fraction, this times this equals the top. And this time this is cosine squared x. So cosine squared x is equal to 1 minus sine x. With cosine squared x, I want to get everything in terms of sine of x's or cosine of x's. And I have a way to convert cosines squared x's to sine x's. Or, in this case, sine squared x. 1 minus sine x. First thing I would do is say, you know what, I can take away 1 from both sides. So I have minus sine x is equal, minus sine squared x is equal to sine of x. Negative sine x. And I could, alright, so I'll bring the sine squared x to the right. So the left side is 0. When I bring the negative sine squared over, it becomes plus sine squared x, minus sine x. So what I'm going to do is, on the left, I'm going to factor out sine x. So sine x times sine x, that gives me sine squared x. And sine x times minus 1 gives me minus sine x. And this is equal to 0. So if this times that equals 0, then either this is 0 or that is 0. Well, if this is 0, that means that sine x is 1. Okay, well, where is sine x 0 and 1? Well, it's 0 at 0 and at 180, but don't worry about 360. So x can be 0 plus 360 degrees, k, which is 360 degrees k. X can be 180 degrees plus 360 k's, and x can be 360 degrees plus 360 k. But that's this one. Write down the two lists, they're the same. Okay, or sine x can be 1. Or sine x can be 1. That happens at 90 degrees. So x can be 90 degrees plus any multiple plus 360. Plus or minus multiples. So those are these three forms of the answers. I don't want to say 3 answers because this is not one answer. It's an infinite number of answers. Excuse me. You get a different answer for each value of k. Okay, that finishes that problem, and that finishes this section. Good luck with them.